Group 3. Here we want to talk about our project, the machine learning methods to diagnose the breast cancer. First, I'll do a short introduction to our topic. The breast cancer is one of the most common cancers among the women worldwide, and the early diagnosis of breast cancer can improve the prognosis and the chance of survival significantly, and the machine learning is widely recognized as the methodology of choice in breast cancer pattern classification and forecast modeling. In past years, the researchers has do many related research to this topic. We can say that Dylan used a large data set which has more than 20,000 cases to get a result that the DT and the AN model were better than linear regression. And Amarin's compares between the two new implementations and evaluate their accuracy and using cross-validation. And they get the KN model achieved a higher efficiency than NB model. And Ahmad Alg's research suggests that SVM are the best classifier predictor, followed by AN and DT model. Then I want to talk about our data set. The data set we use was made publicly available through the UCI machine learning repository, and it has 13 attributes. And the first is ID number, second is diagnosis. In our code, we use 1 to replace the malignant and 0 to replace benign. And there are other 10 attributes. The radius, texture, perimeter, area, smoothness, compactness, convexity, concave points, and they can help the program to do a better classification.
Well, thanks for my partner. Then I will do the introduction about the methods we used in the project. First is about the recursive feature elimination. This method is a gradient algorithm-based feature election technique that recursively eliminates less important features from the dataset to improve the performance of a machine learning model. Then is about the cross-validation. This method is a technique used in machine learning to evaluate the performance of the model by dividing the dataset into multiple subsets and training and testing the model on different combinations of these subsets. Then is about our prediction model. The first one is random forest. Random forest is a machine learning technique that uses multiple decision trees to improve prediction accuracy and prevent overfitting. It randomly selected subsets of features and data points to build each tree and combine the result to make a final prediction. The second prediction method is MLP. MLP is a type of artificial neural network model that consists of multiple layers of interconnected nodes, enabling it to learn and make prediction on complex patterns and relations in data. Then I will show you the result of random forest. From the table you can see the performance of random forest is increasing with feature selection and decreasing with tuning hyperparameters. For tuning, first I use random research to explore the upper approximate range of hyperparameters, and then apply grid search to find the best hyperparameters. However, from the result, it seems that we don't find the best hyperparameters. From the right picture, you can see at the number, or when the number of feature is 15, the model gets the best performance.
Okay, then let me talk about the results of MLP model. First, we can see the table 2 shows the accuracy and AUC ROC of the MLP model. As the random, just like the random forest model, the performance is increasing with feature selection, and we can say both of them are very high. From the figure 2, we can find when the feature selection is 20, the model has the best performance.
Then let me do the conclusion. First, we find that the performance of the model has improved after applying the feature selection methods for both the random forest and MLP model. The second finding is that the neural network model MLP outperforms the baseline model random forest. However, there are some limitations in our project. First, since the dataset we used for classification is relatively old, we are uncertain about the current validity of the dataset. Second, the features in the data may exhibit multicollinearity, which can potentially impact the performance of our model. In future, we will solve these two limitations and adjust the hyperparameters to get a better result. This is our reference. And thanks. And do you have some questions?